Hello guys, this is Siddharthan. If you are new to this channel is all about artificial intelligence and machine learning stuff. So in this channel, I will be posting 3 videos per week. So 2 videos will be on the basics of machine learning, so basic concepts and topics, and one video will be a detailed use case or a project in machine learning. Okay, so the basic videos will be posted on Monday evening and Wednesday evening, and the project video will be posted on Friday evening. Okay, so in this video, we are going to discuss about one of the interesting use cases in machine learning. So it is rock versus mine prediction using SONAR data. Okay, so we will do all the programming in Python, and you don't need to install any Python software. So we will be using Google Collaborator. So Google Collaborator is a cloud-based system where you can write your Python script. So you just need Google Chrome for it. So I'll show you how you can access it later in this video. First of all, let's try to understand more about this use case. Consider there is a submarine. Okay, so there is a war going on between two countries. So submarine of a country is going in underwater to another country, and the enemy country have planted some mines in the ocean. Okay, so mines are nothing but the explosives that explodes when some object comes in contact with it, right? So there can also be rocks in the ocean. So the submarine needs to predict whether it is crossing a mine or a rock. Okay. So our job is to make a system that can predict whether the object beneath the submarine is a mine or a rock. Okay. So how this is done is the submarine sends a sonar signal. Okay. Sorry, a sonar uses a sonar that sends sound signals and receives it back. So this signal is then processed to detect whether the object is a mine or it's just a rock in the ocean. Okay, so let's try to understand how we are going to do this. First of all, let's see the workflow for this project. First of all, we need to collect the sonar data. Okay, so how this data is collected? So what happens is in the laboratory setup, an experiment can be done where the sonar is used to send and receive signals bounced back from a metal cylinder and some rocks. Okay, so because the mines will be made of metals, right? So we collect this data, which is nothing but the sonar data which we obtained from a rock and a metal cylinder. Okay, and we use this sonar data and we feed this sonar data to our machine learning model, and then our machine learning model can predict whether the object is made of metal or it is just a rock. So this is the principle we are going to use in our prediction. Okay, so first we need to collect the data. Okay, so once we have the data, we will process the data. So we cannot use the data directly, so we need to pre-process the data. So there are various steps in that which we will do in this video. So we need to analyze the data, so we need to understand more about it. So once we process the data, we will split it into training and test data. Okay, so why we are splitting the training and test data? Because so let's say there are 100 examples, so 100 instance of data. We will train our machine learning model with 90 instances, and we will test our machine learning model. So we evaluate our model with another 10 data points. Okay, so there are totally 10 100 data points. We may use 90 data points for training, and we can use another 10 or 20 data for testing our model. Okay, so once we split our data into training and test data, we feed it to our machine learning model. So in this video, in this use case, we are going to use a logistic regression model, because logistic regression works really well for binary classification problem. So this problem is a binary classification problem because we are going to predict whether the object is a rock or a mine. Okay, so we'll be using a logistic regression model, and this is a supervised learning algorithm. Okay, so once we train our machine learning model with the training data, we will get a trained logistic regression model. So this model has learned from the data on how a metal cylinder will be and how a rock will be. So this model can recognize it based on the sonar data. Now, when we give a new data, it can predict whether the object is just a rock or it is a mine. So this is the workflow we will be following in Python to make this, script for this use case. Okay, so now let's go into the coding part. So before that, I'll show you the data we have. Okay. So this is the data, sonar data.csv. So it is in a CSV file. So you can find this data in Kaggle and other data sites like UC machine learning repositories and other sites. So I will be giving the link for this file in the description of this video. Let's try to look at this video. In this data set. So as you can see here, there are a lot of numbers. So there are a lot of columns. So let's see there are how many instances. So there will be almost 200 examples. So as you can see here, there are 208 examples. That means 208 data points. So on the in the last column we have something that tells R and M. Okay, so R represents the values for rock and M represents the values of mines. Okay, so as I told earlier, these values are obtained in a laboratory setup where the sonar data is collected for a metal cylinder and for a rock. So as you can see here, there are several features. So features represents the columns of this data set. So we feed this data set to our machine learning model and it can learn from this data on how a rock can be and or how a mine can be with the help of this sonar data. Okay, so let's see how we can make this Python script. So I'll close this. So as I told earlier, we will be doing our programming in Google Collaborator. So search for Google Collab. So this is the website for it. So collab.research.google.com. Okay, so you just need to choose new notebook here. So this Google Collaboratory will be linked to your Google Drive account. So if you have any collaboratory files, so it will show up here. So I'm going to use a new notebook. So these are nothing but Python notebooks, as you may have noticed this in Jupyter notebooks. So it has an extension of 5pynb. So it is just like Jupyter notebooks. So as you can see here, it is a .pynb file which is known as Python notebooks. So I'll change this file name as rock versus mine prediction. Okay, now you can see this connect button here. So go ahead and connect this. So what happens is our runtime gets connected to a Google server. So it is completely free. Google Collaborator is completely free. So you will be allocated a system of a very good storage size and very good RAM. So as you can see here, so we have 12 GB of RAM and 107 GB of storage, which is really good. So it is better than most of our systems. So we will be doing all our programming in Google Collaboratory. Okay. Okay. So as you can see here, this is called as a cell. So we will write our Python scripts in this cells. So as you can see here, you can give this code option to create another cell. So if you give this text, you can write some comments or a description about your code. Okay. So I will tell about the features of this Google Colab once we use it for different purposes. So as you can see here, this is where we will upload our data files. So I have already shown the Sonar data file for you. So how you can upload is, so you can click this folder option here. So there, either you can choose this. So it is to upload a particular file, or you can right click here and click upload. So I'll upload the Sonar data. Okay. So it is a very small data file. So you can find it in Kaggle or UCI machine learning repository. Okay. So as I told here, our agenda here is to predict whether the object is a mine or a rock using the sonar data. So first of all, we need to import the libraries we want. So import the dependencies. So we will require several functions and libraries for this. So I'll write a comment here. So as I told you earlier, so this is for writing description and comment about your code. So I'll just type importing the dependencies. Okay. So you can press enter or you can press shift plus enter to complete it and go to the next cell. Okay. So once you write a Python script, you can click here to run your code, or you can press shift plus enter to run this code and go to the next cell. Okay. So first we need to import some libraries. So we will require NumPy for this. So I'll import NumPy as NP. So import NumPy as NP, and we also need pandas. So import pandas. as PD. Okay, so NumPy is basically for for arrays, and pandas is for several data processing steps. So we will see about that later. Now we need train test split. Okay, so we have seen earlier that we need to split our data into training data and test data. So we will require a function for that. So from sklearn dot model selection, import train test split. Okay, so this function is used to split our data into training and test data, so we don't need to do it manually. Okay, so then we need our logistic regression model. So sklearn is a very good Python library for machine learning algorithms and other functions. So we will encounter it in various different places here. There is a small mistake here. Sklearn dot model selection. So import train test split. Now we need to import our logistic regression model. So sklearn dot linear model. So this is how you can import logistic regression. So input logistic regression, and we need the function accuracy score. So from sklearn dot metrics, input accuracy score. So this is used to find the accuracy of our model. Okay, so these are the libraries and functions we need. So first we import numpy. So numpy is used for creating numpy arrays. So and pandas. So pandas is used for loading our data and numbers into good table. So these tables are called as data frames. So we will discuss about this that in a later point. So then we have train test split. So we import it from the library sklearn. Then we have imported the logistic regression model. Then we have imported the function accuracy score. So you can press shift plus enter to run this cell and go to the next cell. Okay, so if you have any printing output, it will show here. Okay, now let's do the data collection and processing steps. So I'll just put a text here, data collection and data processing. Okay, so we already uploaded the data. There are several methods to upload data in Google Collaborator. We can upload the data straight to Collaborator using some APIs. So we can do it with Kaggle APIs. So we will discuss about it in some other project video. So as you can see here, we have the SONAR data file here. So now we need to import this SONAR data into a pandas data frame. Okay, so I'll make a comment. So in Python, if you write something prefixed by hash, you can comment it. So loading the data set to a pandas data frame. So I'll create a variable called as sonar data. I will be loading this uh, data to a data frame, and I have named this data frame as sonar data. So as you can see here, I have imported pandas as PD. So this is just like an abbreviation. So I'll be using this abbreviation. So pd.read.csv. So as I have told you earlier, we have the data file as a CSV file. So we need to use the function read CSV. Okay. So now we need to mention the name of the file, name and the location of the file. So you can do it by, you can go here and click here. So there you will see this option called as copy path. So this will copy the path and name of the file. So we have to enclose it in quotes and put it in this brackets. Then so as you can see here, we don't have a header file for this. So as you can see here, we don't have any header files. Header files means a name for the columns, right? So there is no header file. So we need to mention in our pandas data frame that there is no header. So header is equal to none. So I'll press shift plus enter, and this loads our data to a pandas data frame. Okay, now let's have a small look at our data set. So I'll just type sonar data dot yet. So what this function yet does is it displays the first five rows of our data set. Okay, so I'll run this. So as you can see here, we have first five rows of our data set, and there are several columns. So as you can see here, there are 59 columns, but actually it's 60 column because in Python the indexing starts from 0. So totally we have 61 columns, and 59 columns we have 59 features, and we have in the last column we have R or M. So I have shown you, right, it's either rock or mine, so it is that categorical value. So this is the use of this get function. It tries to, it prints the first five rows of our data set. Now what we will do is, let's try to see how many rows and columns are there. So number of rows and columns. So if you are not if you don't understand any functions, you can just search in Google about, let's see. So you want to know what this read CSV function does, so you just can go to the pandas documentation. So pandas dot read CSV. So this is the pandas official documentation page, so you can go here. So you will so we can see the use of this particular function here. So as you can see here, it read a comma separated value CSV file into a data frame. It supports optional iterating or breaking the file into chunks. So you can do this for any functions. So in order to learn what this function actually does, so these are the parameters. So we don't need all these parameters. So in our case, we have used only two parameters, which are the path of the file, and we have included that there is no header. Okay, so if you have any doubt about any function, you can search it in Google like this. Okay, so now we need to find the number of rows and columns. So we can use it, we can find it by using the function called as shape. So sonar data dot shape. So this gives us how many rows and columns are there. So totally we have 208 columns and 208 rows and 61 columns. The last 61st column tells us whether it is a rock or a mine, and there are totally 208 rows. So 208 rows means there are 208 instances or examples of data. Okay, so and 61 represents the feature. So let's say for this zeroth instance, so it is a value for one rock, and there are 60 features for this one rock, and it is labeled as R. Okay, so like this there are 208 instances. Now what we will do is, let's try to get some statistical definitions for this data. So sonar data dot describe. So this gives the mean, standard deviation, and other parameters for our data. Sorry, just made a small mistake here. Sonar data dot describe. So as you can see here, it gives the count. So count represents the number of instances we have for the 0th column. So like this we have all the way up to 59th column. So it gives us the count, so the number of values we have, the mean of this column, standard deviation for this column, minimum value, 25th percentile, 50th percentile, 75th percentile, and what is the maximum value. So percentile means like 25% of the values are less than this 0.0133 for first columns, and 50 percentile means 50 percentage of the values are less than 0.022. So that is what percentile is. So for some use cases, it is really important for us to find this mean and standard deviation. It gives us a better understanding of the data. So hence you can use this describe function to get some statistical measures. So I'll just make a comment here. So describe gives statistical measures of the data. Okay, now let's try to find how many examples are there for rock and how many examples are there for mines. Okay, so we can do that by sonar data dot value counts. So this value counts function uh, gives us how many rock and how many mine examples are there. Okay, so I have to include one more thing. So we just need to put a 60 here. The 60 is nothing but the column index. So as you can see here, the rock and mines are specified in the 60th column. So I'm specifying 60 in this value count. So value count function. Okay. So why I am using Sonar data? Because I have loaded this data frame into a variable called as Sonar data. So that's why I'm using this Sonar data and including the function with this. Okay. So now let's see how many rock and mine examples are there. So as you can see here, there are totally 111 examples are there for mine and 97 examples are there for rock. So it is almost equal, so it is not a problem. So if we have data for one type of instance more, let's say for your example, if we have 1000 examples for mine and we have only 500 examples for rock, then our prediction won't be very much good. Okay, so if we have almost equal number of examples for both the two categories, so our prediction will be really good and we will get a very good accuracy score and our model performs well. Okay, so it is almost equal here. So actually speaking, so totally there are almost 208 instances, but this is not sufficient for a machine learning model. So we may require even thousands and several thousands of examples for making a better model, but we are just looking at some examples, so we are okay with this. So you just need to note one thing: more the data, more accurate your model is. Okay, so I'll just represent here that M represents mine and R represents rock. Okay, now let's try to group this data based on mine and rock. So sonar data dot group by 60 dot mean. So now I'll explain you what is the use of this. So as you can see here, so we got the mean value for all the columns. For a mine, we have the mean value for 0th column as 0.034, but for rock, it is 0.022. As you can see here, there is quite a difference between these two. So this difference is really important for us because using this only, we are going to predict whether the object is either a mine or a rock. Okay, so we just found the mean for each of the 59 columns, sorry, 60 columns. Okay, so the mean value for mine is these values and for a rock is these values, and there is a quite difference between them. Okay, so this is really important for us. Now let's try to um, separate the data and the labels. Okay, so here the data, I mean these numerical values. So these are the features and the last column is the label. So we need to separate this. So we are going to do that. Let's see. So I'll just make a comment here, separating data and label. So this is a supervised learning problem where we train our machine learning model with data and labels. So in unsupervised learning, we don't use labels. So here we have labels which are nothing but rock and mine. Okay, so let's put all the data in the variable X. So sonar data. So I'm going to drop the last column, 60th column. So data dot drop columns is equal to 60. So I'm dropping 60th column. And if I'm dropping a column, I need to specify the axis as 1. So if I'm dropping a row, I will be specifying axis as 0. Okay, and let's put the label in the variable y. So sonar data, so we need to use a square bracket here, 60. Okay, so what I'm basically doing here is I'm storing all the values in X except the last column. So I'm dropping the 60th column and I'm storing the 60th column in y. Okay, let's try to print and see this. So print X and print Y. So as you can see here, now there are only 59 columns. So actually it's 60 column and it starts with 0 and the last label is in the variable called as Y. So we have successfully splitted the data and the labels. Okay. Now what we will do is we will try to split this data into training and test data. Okay. So let's include a text here. training and test data. So as we have already imported the function train test split, so we'll be using this function to split our data. Okay, so we need to give some variable names here. X train, so you can give any names here, so for convenient purpose I'm giving this name. So X train, X test, Y train and Y test. So this order should be followed. So first we will take the training data and the test data, then we will take the labels of training data and labels of test data is equal to train test split, and we have to include this X and Y here. So we are going to split this X and Y into training and test data. So X comma Y. So there are several parameters here, so I'll explain you about that. So X comma Y, test size, let's have the test size as 0.1, and stratify is equal to Y, and random state is equal to, let's say, 1. Okay, so now let's try to understand about these parameters. So we are going to split our data into X train and X test, Y train and Y test. So X train is nothing but the training data for this, and X test is the testing data, and Y train is the label of those training data, and Y test is the label of the test data. Okay, so now we are using the function train test split. Then in the parameters we have included X and Y, so we are going to split this X and Y into training and test data. So here we have the parameter test size. So test size, like if we give 0.1 means we need 10 percentage of the data to be test data. Okay, say for example we add almost 200 examples. So what happens is, like, 10 percentage of 200 is 20, so we will have 20 test data. So that is the use of this test size. You can use 0.1 or 0.2, so based on the number of data you have. Okay, so here we will take just 10 percentage of data as training data. Stratify is equal to Y. So stratify, why we are using the stratify is, yes, we need to split the data based on rock and mine. Say for example we need to have almost equal number of rocks in test data, training data, and equal number of mines in the training data. Okay, so hence we include this stratify. So our data will be splitted based on the number of these two, rock and mine. Okay, and then we have random state. So random state is to split the data in a particular order. Say for example if you do the same code and in the code you include 1, your data will be splitted in the same way as my data is splitted. So if I put 2 here, so my data will be splitted in a specific way, and if you include a 2 in your code, it will also be splitted in the same way. It is basically to reproduce the code as it is. So I'll use 1. Okay, so now we can split our data. Okay, now let's try to see how many training data and test data are there. So print x dot shape, so it is the original data without splitting into train and test, and then we have x train dot shape and x test dot shape. So I'll run this. So as you can see here, in the original X we have 208 examples, and in the training data we have 187 instance, and in the test data we have 21 instance. Okay, so we have 21 test data and 187 training data. Now we need to train our machine learning model with this X train, with this training data. Okay, now let's see how we can train our model. So model training. So we will be using a logistic regression model. So I'll create a variable called as model. So as you can see here, we have already imported the logistic regression function here. So model is equal to logistic regression. So this will load this logistic regression function into the variable model. Now we are going to train the model. So training the logistic regression model with training data. Okay, so for that we use the function model.fit. Here we need to include the training data and training label, okay, which are x train and y train. Okay, so let's see what is this x train and y train ones so that you can understand it. So I'm printing x train and also y train. So this is the training data. So x train is the training data and y train is the training label. So as you can see here, we have the data here. So totally there are 187 examples and 60 columns, and this is the label. So as you can see here, it is kind of random because we have used the training testing split. Okay, so now we are going to feed this training data and this training data's label to our logistic regression model. So that's why I've included model.fit x train and y train. So when I run this, our model will be trained. So if you are having a lot of data and if you are using a complex model like a neural network, it will take a lot of time. So here we are seeing a simple example and simple data, so it doesn't take much time. Okay, so our model will be trained. So these are some parameters of our model. Now let's see how our model is predicting. So now let's check the accuracy score of our model. So now we are going to evaluate our model. So model evaluation. So we have imported the function accuracy score for it. So we will use this function to find the accuracy of our model. Accuracy on training data. So first let's find the accuracy on the training data. So what's happening here is, so we will use this same data, the data which the machine learning model has learned. So we will try to use this model to predict these examples. Okay, so then we will use the test data. Okay, so what is the significance here is, the model has already seen what is this test data, sorry, the training data, but it haven't seen what is this test data. Okay, it is just like preparing for an exam. Let's say you are preparing all the example problems in a mathematics book for your exam. So those example problems are nothing but the training data. So in the exam, a new problem will be asked and you need to solve that, but you have never seen that question, right? So that is nothing but the test data. So we need to test our model for accuracy on training data and the accuracy on test data. So it is always, in most of the cases, the accuracy on training data will be more because the model has already seen this training data, and most of the times the accuracy on test data will be less. Okay, so if the accuracy of your model is somewhere greater than 70%, it is actually good. So and it also depends on the amount of data you use. So as I have told earlier, so if you use many data points, and if you use a better model, you will get a good accuracy score. Okay, so if we use quite less number of data, as we have in this case where we have only 200 data points, our accuracy can be low. Okay, so but the idea of this video is for you to understand how you can implement these steps. So the accuracy is not that much important, but we have to note here is, so any accuracy greater than 70% is good. Okay, so now let's try to predict the training data. Let's train prediction is equal to model dot predict let's train training data accuracy. So we will store this accuracy value in this variable training data accuracy. So training data accuracy is equal to accuracy score so this is the extreme prediction is the prediction our model makes, okay, based on its learning. So we need to include extreme prediction and all the correct values, it is y train. So okay, so what happens here is we are going to compare the we are going to get the accuracy score. So X-train prediction is the prediction of our model, and Y-train is the real answer of this instances. So as you know here, so we have this test data, right? So X test and Y test is the label of this test data. So now what happens is we are going to compare the prediction of our model and the original label of these data. Okay, by that we will get the accuracy score. So let's try to get the accuracy score for the training data. So I'll print the accuracy score. So accuracy on training data. So I'll copy this. So this will have the accuracy score here. Training data accuracy. So as you can see here, we got almost 83.4 percentage of accuracy. So it is actually kind of good for these many data. So now let's try to find the accuracy score of test data. Okay. So it will be the same part except for some changes. We just need to include the test data here. So accuracy on test data. So X test prediction. Test data accuracy. So the model has never seen this data. Okay, so model.predict X test. Okay, so Y test. So now we are using our model to predict the test data, and this prediction of this model will be compared to the original labels, which is Y test. Okay, test data accuracy. Now we need to print this accuracy score. So accuracy on test data. Test data accuracy. So we got a 76% as accuracy score, which is really good. So which means out of 100 times it can predict 75 times the correct object, whether it is a rock or mine. Okay, so we got accuracy score as 83% for training data and 76% for test data. So our model is performing fine. Okay, so now let's what we are going to do is, so we have a trained logistic regression model, and now we are going to make a predictive system that can predict whether the object is either rock or it is mine using that sonar data. Okay, so now let's see how we can make this predictive system. So making a predictive system. So we need to give the input data. So I'm making a variable called as input data. Okay, so in this parenthesis, we need to include the sonar data. So we have seen this sonar data, right? So we will be taking some examples for rock and mine, and we will check whether our model is predicting the rock and mine correctly. Okay, so this is the use of this code snippet. So once I complete the script, I'll copy some values and put it, and let's see whether it's predicting correctly. So input data. So once we get the input data, we have to convert it to a numpy array, because the processing on numpy array is faster and it's more easy. So it's basically changing the data type to a numpy array. So a list to a numpy array. So changing the input data. So I'll just make a comment here. So changing the input data to a numpy array. So we will use the function numpy.asArray for this function. So input data as numpy array. So this is the variable I am giving it. So input data as numpy array is equal to np.asArray. So if you remember, we have imported the library numpy as np. So I am using np instead of numpy. Okay, so np.asArray input data. So basically we are converting this list into a numpy array, and let's take an example. Say for example, And I'll open this from a notepad. Okay, so let's take some random example. Okay, let's take it. I think it is a rock. So as you can see here, this example is rock. So if we feed this data to our machine learning model, so it should predict that this is a rock. Okay, so I'll copy this. Okay, so put this in this input data. So we have totally 60 features. So I have converted this input data. So this is basically a list. So we are converting it to a numpy array. Okay, now we need to reshape the data. Okay, so because we are just predicting for one instance, so for that purpose we need to reshape this array, otherwise our model can be confused by the number of data points. So we need to reshape the numpy array as we are predicting for one instance. Okay, so input data reshape is equal to, I'm copying this, so input data is numpy array, so we need to reshape this, reshape 1 comma minus 1. So this 1 comma minus 1 represents there is one instance and we are going to predict the label for this one instance, so that is why we are reshaping this. So once we reshape it, we need to make the prediction. So I'll create a variable called as prediction and I'll store the prediction of our model. So model.predict function is used to predict it. So we have stored our trained logistic regression model in the variable called as model. So as you can see here, so I'm calling that model function, so model variable. So model.predict this input data reshape. So this contains the features of our data. Okay, so this data is present in input data reshape. Okay, so basically what happens is that this model.predict returns either r or m as value. Okay, so it tells us whether it is either a rock or a mine. Okay, now let's try to print this prediction. So let's try and run this. So it should predict that this object represents a rock because we have copied the data for a rock, right? So I'll run this, and yeah, it predicted correctly that the object represents rock from this example. Okay, and let's include a if condition here that if we get r as our prediction, it should say that the object is a rock, and if we get m, the object is a mine. Okay, so as you can see here, this r is included in a list. So if this prediction is equal to r, prediction 0 is equal to r. So I'm using this 0 because this 0 represents the first element of the list. Here the list is this prediction. Okay, so the first element is r and we need to represent it with this index as 0. So that's why I'm using 0 as the index here. So if it is not in a list, I won't include this as 0. Okay, so if the first element of this list is equal to r, we need to print that the object is a rock. Okay, otherwise, so else we need to print it is a mine. So when it is m, we need to print it is the object is a mine. Okay, let's try to run this. So as you can see here, so we get the first element in the list as r. So it tells us the object is a rock, and we know that we copied the data of a rock. Now let's try to see whether our model is predicting the mine correctly. So let's try to get some random value for mine, and let's try to let's find whether our model is predicting correctly. I'll take this value. So this value represents mine. As you can see here, there is an M. So I'll copy this value. Let's see whether it's predicting correctly. So if our model is working correctly, it should say that it is M, which means that the object is a rock. So I'll just replace this. Okay. Now let's try to run this. Now it should say that the object is a mine. So as you can see here, it is predicting correctly that the object is a mine. So this is how our predicting system works. So I hope you have understood all the process we have done here. So I'll just give you a short recap of how we are doing this. So first we have imported the dependencies. So NumPy is used for making arrays, and pandas is used for making a data frames, and we are using the libraries sklearn for using the function train test split. So it is used to split our data into training and test data, and in this case we are using a logistic regression model. So we are importing that logistic regression function from sklearn.linear model, and we are importing the accuracy score to find the accuracy score of our model from sklearn.metrics. Then data collection processing. So we have imported the sonar.csv file into our Google Colab environment. Okay, so now we are feeding it to a pandas data frame by pd.read csv function. So, and I am storing that data frame in a variable called as sonar data. So here we need to give the path of the file, and since we have no header in this file, so we have to mention that there is header is none. And by the function head, we are just printing the first 5 columns of our pandas data frame, and we find that the last column is a categorical column which says whether it is a rock or a mine. So R represents rock and M represents mine. Then we are determining the number of rows and columns we have. So we have 208 columns which represents 208 data points. So and 61 features. Okay, so 60 features and one label which is rock or mine. Then we have used the function sonar data.describe, which gives us the count, the number of values we have, mean and standard deviation and other statistical values. Then we are counting how many mine examples are there and how many rock examples are there, and we find out that it is almost equal. And then we are grouping the data based on mine and rock, and we find their mean values, and we get a quite difference in their mean values. Okay, so as you can see here, there is a difference in mean value of rock and mine for each of the column. Okay, so now we are splitting the data into all the features and all on the labels. So we are feeding all the features to the variable x and all the labels to the variable y. Okay, now we are splitting our x and y, our data, into training and test data. Okay, so the training data is used to train our model, and our model is evaluated with the help of test data, right? And then we are loading our logistic regression model in the variable model, and by the function model.fit, our model is trained. It is just like a graph. Okay, so in the x-axis there will be this features, and the y-axis there will be labels. Okay, and the graph will be plotted. So this is how model is trained. So once we have trained our model using the function model.fit, we are finding the accuracy score. So first we find the accuracy score of training data, which is around 85%, 84%, and then we find the accuracy score for the test data, which is around 76%. Then we are making a predictive system where if we give the features, if we give the data, it can predict whether the object is a rock or a mine. Okay, so this is how these are all the procedures we have used in this use case. So I hope you are clear with all these. So I will be giving the link for the sonar data, so the data file, and also this collab file in the link of the link in the description of this video, so you can download it from here. So do try Google Colab. So try to do all these things we have done here. Okay, so try to write all this Python script by your own and try to understand it. So if you have any doubt, if you run into any problems, mention in the comment. I'll try to solve your problem. Okay, so that's it from my side. I hope you have understood the topic we are covered in this video. So I'll see you in the next video. Thanks for watching.